unfair pricing in supermarkets across Trinidad and Tobago by R.T. Ramdhanie. Co-host?
The machine learning techniques for the detection of unfair pricing in supermarkets across Trinidad and Tobago. So, a brief introduction. Given the current state of the economy in Trinidad and Tobago, consumers should be given the opportunity to monitor the prices of standard grocery items. The Ministry of Trade and Industry collects prices for 118 standard grocery items every month in 49 supermarkets. The task has fallen solely upon the Consumer Affairs divisions of the ministry. The consumers can use price tracking to avoid supermarkets which have unfair pricing schemes. The task of identifying which supermarkets are non-conforming is linked to the total basket price, which is the total cost of the 118 items. So there were two aims and objectives for this paper. The first is using feature selection methods to reduce the number of items being tracked. If you have less items being tracked, then less time, effort, and manpower would be spent by the ministry in this price monitoring effort. The other objective is developing a binary classification and machine learning model which would be used to identify non-conforming supermarkets. So the data was obtained from the Ministry of Trade and Industry's website under their 2018 publications. It was 15 individual files which were cleaned using the Power Query Language M, which was developed by Microsoft. A script was then developed to pivot, encode, and merge these 15 sheets into one master database. The structure of the database is seen in the image below. We have the grocery, the month, and the area. Then we have columns V1 to V118, which represents the pricing info for all 118 items across all supermarkets. Here we have a spatial representation of the 49 supermarkets being monitored across the country. As you can see, it's equally distributed between north, south, east, and west, and Tobago, so we can get an accurate representation of the pricing across the country. This is a time series representation of the standard basket price over time for North, South, East, Central, West, and Tobago. So a big step in the data cleaning process was identifying the initial outliers. An outlier is a data point that varies significantly from all other observations and lies outside the general pattern of distribution, as seen in the image below. So when dealing with outliers, the question which must be addressed is what should be done with them. They can be introduced into a data set in several ways. You have genuine extreme high and low values in the data set, or introduced by human or machine error. If the outlier can be classed as a mistake or a misrepresentation of data, then we can simply discard it. However, if the outlier is a true value, then it is critical that it be kept because useful information will be lost if it is discarded. So in this data set, the outlier was identified as the total basket price, which exceeds more than 5% of the average basket price for that month. An outlier column was added to the data set. If a supermarket was an outlier, a 1 would be the outlier value as opposed to a 0, which represents a non-outlier supermarket. So after the previous cleaning and pre-processing step, the distribution of outliers to non-outliers was highly imbalanced. We had 98.84% of non-outliers and 1.16% of non-conforming supermarkets. So a data set is identified as imbalanced if the classification targets are not equally represented, like this one. It's prominent in problems like credit card fraud, identification of rare diseases, and email spam classification. So imbalanced data sets do not perform well with traditional machine learning algorithms, so we need to perform resampling. So the technique used for resampling is SMOTE. It stands for Synthetic Minority Oversampling Technique. It is done in order to obtain the same number of instances of the target classes. It is done on the training set alone. For this process, it creates synthetic observations based on the existing minority class. So it uses the existing data points for outlier supermarkets and creates synthetic data points to balance the data set. So after SMOTE, we had 46.65% outliers versus the 1.16 and 53.35% non-outliers. So the feature selection objective mentioned before is a technique of extracting a subset of relevant features from the full data set. In this data set, we have input x, where x is 1, 2, up till n, and n is the 118 items, and output y, which contains our target variable, which is 0, 1. In most cases, the output y is not determined by the complete set of features, but some subset x1 to xn, where small n is less than big N. So some of the feature selection methods used include manual variance threshold. The variance of each of the 118 items were calculated, and low variance items were removed. The intuition behind this is if it has a low variance, then it has a higher price stability. Random forest. This method finds the weights of attributes using the random forest algorithm. It is a collection of decision trees where each tree is a sequence of 0, 1 questions based on a single or combination of features. We have chi-squared filter. This algorithm finds weights of discrete attributes based on a chi-squared test. It is used to test the relationship of our feature variables against our target variable. It is done using the Cramer's V coefficient to measure the association between variables. Entropy-based filters were also used. The algorithms in this section find feature importance values based on their correlation with the class attribute. The types used, well, 3 types were used in this project: information gain, gain ratio, and symmetrical uncertainty. And then we have the 1R classifier. This algorithm uses the 1R classifier to calculate a feature's weights for each individual attribute and its value. The error produces the error if only that feature was used in the classifier. 1R separates a series of values into many disjoint intervals and evaluates the features according to the error rates obtained. Logistic regression. A little intro on this. It belongs to the family of generalized linear models, and it is a binary classification algorithm which is used when the target response is dichotomous. Certain assumptions are made by logistic regression. The response variable must follow a binomial distribution, and the observation should be independent of each other. There is a linear relationship between the independent variables and the link function, and the dependent variable should have mutually exclusive categories, which mean it must be 0 or 1, and a supermarket cannot belong to both conforming and non-conforming, so it must be mutually exclusive, and the dependent variable should have exhaustive categories. The method used to fit the logistic regression model is achieved through maximum likelihood estimation, and in this project a Bayesian generalized linear model was used as opposed to a GLM in order to combat the problem of separation. So this is the logistic function. It is given by P of y equals 1 given x is equal to the formula on the right. The link function can then be derived from this function, and it is given by log of p over 1 over p is equal to beta 0 plus beta 1, where you have p is equal to big P of y equals 1 given x, and then you have beta 0 and beta 1 is the linear combination of the independent variables, and then you have log p of 1 over log p on 1 over p is the logit function. So in order to evaluate our model, it is important to choose a metric when dealing with imbalanced data. The goal of our model is to essentially test how well it behaves, reacts to unseen and unlabeled data points. So we use the metrics generated from a confusion matrix, where you compare the predicted class versus the actual class. So first, we have accuracy, and this is the proportion of correctly classified data points. We have sensitivity, which is a proportion of positives identified correctly by the classifier. Specificity is a proportion of negatives accurately identified by the classifier. Precision is how much of the classified or predictive positives are actually positive. And then the F1 score, which is a test of the classifier's overall performance. It is a harmonic mean between the precision and recall. So for the purpose of this research, the important metric to note is sensitivity, and it is the proportion, as I said, the proportion of positives correctly identified by the classifier. So this table identifies the results obtained from the experiment. The 7 feature selection methods were utilized in order to eliminate a subset of the 118 items. The results show that the information gain algorithm with a 20% deduction had the best F1 score. The second best performance was by the symmetrical uncertainty algorithm with a 25% reduction in features. It was shown that we can potentially remove up to 25% of the total number of items being monitored, which is approximately 30 items out of the 118 items, without affecting the ability to detect the non-conforming supermarkets using the logistic regression model. So, as mentioned, occurrences of handling imbalanced datasets are proving to be very common in real life. The first goal was to reduce the number of items being collected by the Consumer Affairs Division, and it was reduced by potentially up to 25%, which is approximately 30 items out of the 118 items. And then the second goal was to build a logistic regression classifier to identify supermarkets who are unfair in their pricing schemes, so consumers can be better informed and potentially avoid these supermarkets. Thank you. This is my email. If anyone has any questions, they can send it to me and I will answer them as soon as possible. Thanks. Hi, good afternoon.
Okay. Thank you very much for the presentation. As this presenter is not online for any questions, so any questions to her will have to be sent to the email. Okay, this brings us to the end of this session, the 3rd of June, Wednesday. What I will do now is just wrap up the session by saying that in this session, there were 8 pre-recorded presentations and 4 live presentations. We have a very attentive audience. We have participants at present